offset list. Offset means metric. So just another way of saying metric list. Remember that this might not be available everywhere. This might not be available like in everywhere. So offset list we can use to tune. Offset list we can use to tune the metric value. And if you are if you increase offset list, we can use to increase the metric value. And just in case if you increase the metric value so much that it reaches to infinite, the route is going to be filtered. For example, in protocols such as RIP, you see here, let's go to router number 13. On router 13, I am receiving all these prefixes via RIP routing protocol. And again, I don't want to receive these prefixes maybe on this particular interface on FA0/0. All I can do, configure terminal, access list, 1 permit any, all the prefixes I have matched. I have matched all the prefixes. I want to increment the metric value of all the prefixes. So I have matched all the prefixes here. If you wanted to increment the metric value for specific prefixes, you could have done that for that one as well. And the command router RIP command is offset list, the ACL, then in, then by how many hops you want to increment the metric. I want to increment the metric by 16 hop so that it gets filtered. And on what interface? On FA0/0. So this command means when you receive the prefixes on the interface FA0/0, if the prefixes belong to the ACL 1, increment their metric value by 16. All the prefixes in the ACL 1 will have 16 incremented in the metric if received on the interface FA0/0. In protocols such as RIP, it is possible to set the metric value to infinite. In protocols such as RIP, it is possible to set the metric value to infinite by using this offset list and incrementing the metric value to, let's say, 16. As you can see, do show IP route RIP. You don't have the route on the other interface now, because all the routes that are received onto that interface, they will have much more higher metric, and in RIP, maximum metric can be 16. So when the prefixes are getting advertised, they are getting advertised with the hop count value of 10 plus 16, the metric value goes to 26. So that's why they are not available. In protocols such as RIP, RIP uses hop count as a metric value and maximum hop count limit is 15. So we can increment the metric value to 16 for any prefix to make it unreachable, because the metric will be considered as infinite. So for example, we wanted to filter all these prefixes. So I have used this, I have used access control list to match these prefixes first of all, and then use the command offset list number 47. In or out means like incoming prefixes will, you want to increment the metric value, or you want to increment the metric value for outgoing prefixes, then by how many you want to increment the metric value, and then in what interface. It is possible in protocols such as RIP, it is possible in protocols such as RIP to set the metric value to infinite. It is possible in protocols such as RIP to set the metric value to infinite by setting the hop count value 16. However, this cannot be done for EIGRP. This cannot be done for OSPF. We cannot go in EIGRP. No. See, if you go to, let's say, router number 12. Okay, let's go to router number 12. Let me filter all these. Now, show IP route EIGRP. I have all the prefixes. Let's say I do not wish to receive any prefix onto this particular interface, and we are asked to filter these prefixes with the help of offset list. We actually cannot do that. We cannot do that. If you go to router number 12, access list, 1 permit any, you have matched all the prefixes. Then router EIGRP, offset list, all the prefixes that match in the ACL number 1, all the prefixes that are permitted in the ACL number 1, I want to increment their metric value. So offset list number 1 in, that means when the prefixes are received, I'm going to increment the metric value, and this is the maximum number that you can use to increment the metric value. If I write down 8 here, it will just not accept it. So the maximum number is this one. On which interface? On the interface FA0/0. It doesn't matter actually. You do whatever you want to. Even see, all the prefixes that were being received on the interface FA0/0, they already had some metric value. And now the metric value will be incremented by this much. But still, you see, now on one interface, the metric is lower. On one interface, the metric is higher. So you have done path manipulation, but the filtering did not take place. You can see that. So IP route EIGRP, do show IP route EIGRP. You can say that, okay, I am receiving only one prefix, so might be that the prefix other subnets got filtered. The prefixes on this interface got filtered. That's not the case. Interface FA0/1. If you shut it down, because since now you have incremented the metric value, since you have incremented the metric value on the other interface, this path will not be considered as the best path, but these routes are not filtered, and you can check it by shutting down the other interface. You can see do show IP route EIGRP, and you can see all those prefixes are still there. So in protocols such as EIGRP, it is actually not possible to set the metric value to infinite by using this offset list. By using this command, it is just not possible. Because if you are aware, classic EIGRP, 32-bit metric, 4.2 billion is the highest possible metric value. Named EIGRP, 64-bit metric value, 2 raised to the power 64 metric will be considered as infinite, which we cannot set. This is more like I think half of that limit that we have. So in the offset list, in the EIGRP, and in OSPF, in protocols such as OSPF, we don't even have the option of like configure terminal, router OSPF, offset list. We don't even have the option of offset list. Offset list is available in RIP and EIGRP protocol. In case of RIP, it can be used for path manipulation and route filtering. In case of EIGRP, it can only be used for the path manipulation. Somehow, if you can make the metric value go infinite in EIGRP, means somehow if you can increment the metric value so much that it reaches to this number or reaches to this number, then only that prefix is going to be filtered, otherwise not. And this is not possible with the help of the offset list, because offset list gives you the number maximum to maximum this one, which is nowhere near to 2 raised to the power 32, which is nowhere near to 2 raised to the power 64. So in EIGRP protocols such as in OSPF, we don't even have the option of the offset list, because offset means metric, and in OSPF we can increment and decrement the metric directly on the interface. So we don't even have the option of offset list. Offset means metric, and metric can be incremented, decremented directly on the interface in OSPF. No need to use offset list for the same purpose. In EIGRP, the offset list can be used to influence which part becomes the best part. And you can use this offset list. You can use this offset list. Let's say this is a router 12. It is receiving same subnet on 2 paths. One path is successor, one path is feasible successor. You have adjusted the variance so that the unequal cost load balancing is taking place. But unequal cost load balancing is not taking place in the ratio that is expected, such as I told you a question that you need to perform the load balancing in 3:4 ratio, let's say, for example. So the load balancing is not happening in this ratio. So to influence, to basically do the load balancing in an appropriate ratio, we can also increment the metric value respectively here so that the load balancing takes place accordingly. Offset list can be used to influence the metric value, and since based on the metric value it is decided like how the load balancing can take place, and equal cost load balancing can take place, so that can now also be achieved. Okay, now a question here that you need to find the answer yourself. In protocols such as RIP, when we use the offset list, it is going to adjust the hop count, because hop count is the metric value for RIP routing protocol. In case of OSPF protocol, if you wanted to do the same, there is no option of the offset list, because we can directly influence the cost under the interface. In both the condition, this offset this hop count is a single numerical value. In the cost is a single numerical value derived with the formula 100 upon bandwidth. There is no formula for this hop count, it is just hop count. The question is, in protocol EIGRP, if you remember, we are using the offset list. We are using the offset list to influence the metric value. We are using the offset list to influence the metric value. I know that in EIGRP, the metric value is a single numerical value. Completely fine, completely okay. But if you remember, this single numerical value that we get in EIGRP as the metric value is calculated based on the parameter called bandwidth, load, delay, reliability, and MTU. So my question is, when we use the offset list to influence the metric value in EIGRP, how does that work actually? In RIP, it works very simply by incrementing the hop count. Okay. In OSPF, we can go under the interface, increment, decrement the cost. That is also okay. But in EIGRP, the metric is not calculated based on one single value. It is calculated based on bandwidth, load, delay, reliability, MTU. Then we have metric calculation formula. In that formula, all these values are put, and then the result is the single numerical value, which represents the metric. Now, let's say in EIGRP, the question is, in EIGRP, let's say for a subnet based on the bandwidth, load, delay, reliability, MTU, based on these metric component, let's say the metric was 1000. And now we have used the offset list to increment this metric value by 500. So now the resultant metric has become 1500. EIGRP cannot just directly make the metric value to 1500 without changing the components. Remember that this metric can only be influenced by changing these components, which you have already done. You have already changed the bandwidth, you have already changed the delay, because these are the things that are used by default. Now the question is, when we use the offset list, to change the metric value administratively, which of these 5 components EIGRP is going to change to influence so that it gets this result? Based on the metric calculation formula, the metric is this one. Now the metric has to be this one. So which component out of these 5 components will be changed by the EIGRP so that this metric is achieved? Again, in EIGRP, metric is calculated based on the metric calculation formula, which uses bandwidth, load, delay, reliability, and MTU component. So when we increment the metric value with the help of the offset list, actually, EIGRP just cannot go and increment the metric value right away. It needs to actually change the components so that it gets the resultant metric that you desire. So which of these components are going to change to achieve this metric value? Let's say, for example, so which of these components are going to change? So maybe it could be bandwidth, maybe it could be delay, maybe it could be load, reliability, MTU. You find that out yourself. But anyway, with the help of the offset list, it is also possible to set the metric value to either infinite or some particular value so that we can achieve primary, secondary. Any questions so far? Let me know. Okay. All of these tools that we have discussed so far, they are good. Like we can use the ACL, we can use named, numbered, standard, extended, prefix list, gateway filter list, area filter list. We can use like offset list. We can use these things to perform the route filtering, to influence the best path and all. We can use all these tools. We can use all these techniques for the same.